Hello everyone and welcome back to Coding with Mock. And in this video, we'll be looking at the synchronized keyword, but not as a synchronized method, but we'll be looking at synchronized code blocks in this video. Synchronized code blocks are a little bit more involved. We have to add something to our synchronized to actually make it work. And we'll be looking also in what might be potential problems using this way of coding, and also the advantages. Okay. Now, the new way or the second way of using the synchronized keyword is not by adding it to the complete method, because this will make my complete method synchronized. And we can also create code blocks that we can make synchronized. We'll just be removing it here from our add method, and let's add it into our code. Now the thing here is that I have to give it something. I have to give it a token. Okay. What this token is will become clear in a minute, but let's create a simple object, a token object, instantiate it, really important here. Now I can give it this token. Okay. You'll see it complaining on a non-final field. It does not need to be final, but it is suggested that you make your object final. Let's make it final, and then it'll stop complaining. Okay. Now, what happens here? Or this is the exact same code as you've seen at the beginning of this video. This is the exact same as if I would have added my synchronized here. So synchronized here, or this synchronized code block, is the exact same thing. Not exactly. Okay. I'll get to that in a minute. But the effects will be the exact same. My synchronized method has now changed to a synchronized code block. The advantages here are, if I would have added a system out print line of my counter here, this does not change my counter. This just reads my counter, right? So there's no issues here, by which I mean, in the previous video, we've seen that concurrency problems will start popping up when you change your shared resource. But I'm just reading my shared resource. There is no problem. You can have 3, 4, 20 threads reading a shared resource, and that will almost never create problems or concurrency problems. Okay, so reading will almost never create problems. If it's a read with side effects, then you might have a problem. But for this example, we're just reading, so no problems here. Okay. The issue here was, if I synchronize all of my code, and my system out print line was something that took a lot longer. Let's say that we are going to ask our database something, and that can take a few milliseconds, then it will slow down the whole of the application. While the only thing I need synchronized here is the addition of my counter, right? So best practice here is, if you have a method that can be a little bit slower, or has parts of it that are slower, and the mutating parts are quick, and usually the only thing that you're going to be mutating are things in memory, so they're usually they are quite quick. So what the best practice here is that you only synchronize the parts that really need synchronization, so the mutating parts. synchronize those. The parts that do the reading or parts that don't truly need um, synchronization, don't synchronize. Okay, that's the best practice here. Okay, now let's see if this code still does what it needs to do. I'll show you that real quickly. And this still worked. I'm still getting 20,000. Just one more time, just to be sure. 20,000. Okay, good. Now, what's the difference? Or what's the difference between this synchronized and this synchronized? Now, the real difference is in my token here. If I use a synchronized in a method, that does this. It synchronizes on the shared object or on the object being on the object where the synchronized can be found. Okay, this will also work. Now the thing here is that this will kind of limit us in what we can do. You can use the synchronized this. It'll work and it'll do its job. But usually what you will find is that you will be using tokens just to make your code a little bit more readable. And especially when you have multiple synchronized blocks, because if you, let's have some more code here, some non-mutating code, right? And now here I have some mutating code. Let's mutate something. Let's do our counter and do counter equals, not equals, +1 again, right? So this is mutating again. Right? Now, let's create a new counter. So let's do private int counter b equals 0. And we'll rename this to counter a. Yes, please. Okay. Now let's say we have our counter a here that's being mutated in this code block. Now I could do this synchronized on this and then mutate my counter b like this, right? So I have one shared resource, my counter class or my counter object, but within my counter object, I have two different resources or two different variables that are being changed. Now, with synchronize this and synchronize this, what this basically does is you can't execute, or there's no thread that can execute this piece of code without having what we call a lock on this object. So think of it as a token that you need to be able to access a piece of code, right? So you need one thread needs to be given this token to access this piece of code. Now, that's how the synchronized method works. Now that we have two synchronized blocks, think of this again. Now we can't, or a thread will be given this token to enter this code. Now another thread might want to enter this piece of code. Now what we've written here is that we're saying that second thread can't access this code without having this locking object or this locking token. Now, because this synchronized code block and this synchronized code block are using the same object, thread 1, who is actually executing this piece of code, is blocking thread 2 from entering this synchronized method because thread 1 has the token, so thread 2 can't get the token because thread 1 has it. So thread 2 is being blocked from executing this code because thread 1 is executing this code, which actually doesn't make much sense, right? If you think about it, because this piece of code is altering counter A, this piece of code is altering counter B. So locking both locking both code blocks with the same object isn't the most performant thing to do. Now, eventually, or in the end, this will give you the correct outcome. Why? Well, because my stuff is synchronized. And the mutating parts are shielded, let's put it that way, and there's no multiple threads coming in there. There's only one thread that can access this synchronized part at a given moment, right? But from a performance point of view, this makes no sense. From an outcome point of view, or an direct outcome point of view, you can defend this piece of code, but performance-wise, this is going to cause performance problems, or not, or your code is not going to be as optimal as you want it to be. Okay. Now, what's the solution here? Well, the solution lies with final object token. And now let's create final token A and final object token B. Simple. And now let's lock this piece of code with token A and this piece of code with token B. Awesome sauce. Okay. Now our performance problems are gone. Okay. Why? Because there's no thread that can access this piece of there are no multiple threads that can access this piece of code or this synchronized block without having token A. But if thread 2 wants to access this piece of code, thread 1 is not going to block it. Thread 1, who's executing this piece of code, thread 2 wants to start executing this piece of code. It asks the scheduler, hey, is token B free? Your scheduler will respond, sure, token B is free. Token A is taken, but token B is free. So your second thread can access this piece of code. Okay, so synchronized blocks, while not really needed for a correct output, performance-wise, they do make sense. Okay, so that's the difference between a synchronized method and a synchronized code block. Okay, play around with this a bit, and hopefully this made sense. If you have questions, put them down below in the comments or post them on Classroom. Okay, good luck, have fun.